Good morning students. Once again I welcome you to my video lectures on control systems. And in the last class we calculated angle of asymptotes. Angle of asymptotes comes into picture only when the root locus branches terminate at infinity. If they are not terminating at infinity, then there is no point in calculating the angle of asymptotes. Now the next comes the question. After calculating the angles, that is the angle of asymptotes, where to mark these angles? The question is where to place the protractor, because we measure angles in the protractor. Where the protractor is to be placed is the question. So to place the protractor exactly, so one has to calculate what is known as centroid. So centroid is the location, is a point at which we draw angle of asymptotes. Therefore, it is essential to calculate what is known as centroid. That is centroid calculation. That is guide number 5. Now, for this guide, I am not giving you the proof. It is not required. And I am stating the centroid calculation. Centroid is a point at which angle of asymptotes are constructed given by centroid equals summation of real part of poles of GSHS minus summation of real part of zeros of GSHS, that is GSHS means open loop transfer function, divided by number of poles minus number of zeros. This is an empirical formula. So using this formula, one has to do what is known as centroid calculation. After calculating the centroid, then one has to draw the angle of asymptotes. Now I will work out a few problems. First problem. K by S square. GSHS equals K by S square. As there are two poles, no zeros, therefore two branches terminate at infinity. So we know how to calculate the angle of asymptotes. And here the poles are at 0 and 0. Therefore, the centroid calculation is summation of poles, summation of real part of poles, that is 0 plus 0. So there are no zeros, divided by the number of poles minus number of zeros, that is 0. Therefore, centroid is nothing but origin. Origin is the centroid. So this is how we calculate the centroid. Now I will take the next problem. The next problem is K GSHS equals K into S plus 1 divided by S plus 5. K into S plus 1 divided by S plus 5. Here in this problem there is one pole and one zero. Therefore, number of branches terminated at infinity is nil, because number exactly poles is equal to zeros. Therefore, there are no branches terminating at infinity. Therefore, there is no angle of asymptote calculation. As there is no asymptote angle calculation, there is no centroid calculation also. No centroid calculation. Now I will take next problem. The next problem is GSHS equals K by S square plus 2S plus 5. K divided by S square plus 2S plus 5. So for this you have to find here K over S square plus 2S plus 5. So now first let us find the poles. So this is a quadratic equation, and the two roots of this quadratic equation are ax square plus bx plus c equal to 0 minus b plus or minus square root of b square minus 4ac divided by 2a. that is minus 2 plus or minus square root of minus 2 plus or minus square root of minus 16 by 2, that is minus 1 plus or minus square root of 4i or 4j divided by 2, that is minus 1 plus or minus 2j. Now formula centroid calculation equals summation of the summation. There are two poles at minus 1 plus or minus 2j. Therefore summation of the real part of the poles minus 1 and there are no zeros divided by 2 minus 0. Number of poles is 2, number of zeros nil. Therefore minus 2 by 2, that is minus 1. Therefore this is how we calculate GSHS equals k into s plus 3 divided by s plus 1 into s plus 6. Now poles are at minus 1 and minus 6. 0 at minus 3. Therefore centroid equals summation of real part of the poles minus 1 minus 6 minus 7 minus summation of the real part of the poles, that is minus 3 divided by 2 minus 1, because there are 2 poles and 1 0. Therefore minus 7 plus 4 plus 3 divided by 1, that is minus 4. Therefore centroid is at minus 4. Therefore on the S plane at minus 4 we have to construct the angle of asymptotes. So this is how we calculate centroid calculation. That completes guide 5. Thank you.